So we're going to start off with some bell work here. 4 problems, as you can see here. The first part is to simplify using exponent rules. So if you remember, we learned that whenever you're dividing two things that have the same base, you subtract the exponents, right? So remember that rule. If you have, let's say, XA over XB, they have the same base, and so when you divide, you subtract the numerator's exponent from the denominator's exponent. So that's what we're going to be doing here. Just a little bit of practice from like old stuff that we've learned. So the 35 and 5 are numbers. So if I take 35 and divide it by 5, that's 7. And for the variables, x with x, when I divide, 2 minus 3 gives me x to the negative 1 power. If I take y to the 5th power, divided by y to the 2nd power, 5 minus 2 gives me y to the 3rd power. Now, I can't leave my answer like this because this here is a negative exponent. So remember, whenever we have negative exponents, we have to put it in the denominator. So I got to put this guy in the denominator. So here's what I'll do. It's going to be the x in the denominator, and now it can be a positive one, whereas my numerator, the 7 and y to the 3rd power have positive exponents. So they're going to stay where they're at, which is the numerator. And that's it. This is my final answer. So I've collected all the like terms, and I don't have any negative exponent. Now I want to show you how to do this problem in a different way that will eventually become more efficient for us to use. Now this is fine. This technique is totally fine. You can subtract the exponents here, divide like normal. But when we get to really complex things, this might not be the most efficient way to simplify. So here's another way we can simplify. So I'm going to rewrite this problem, 35x squared y to the 5th, 5x to the 3rd power y squared. So looking back at this problem, what I'm going to be doing is looking at factors, okay? And so what that means is, like taking, for instance, these numbers here, 35 and 5. What factors or what numbers can divide into 35 and 5? So take a moment to think about what can divide into 35 and 5. Well, 5 can divide into 35 7 times. So I can replace that with a 7. And 5 can divide into 5 1 time. So you can see here, now I'm just left, instead of a 35, I have a 7. And instead of 5, I just have a 1. What this is doing is allowing us to cancel out factors so that we can reduce this fraction. Now, when I look at variables, I'm going to need to take care of them. So what I do is look at the lowest power. So the lowest power is on the top. X squared is the lower power here. So what I do is I'm going to cancel out x squared in the top and the bottom. Well, if I cancel out x squared in the top, it gets all canceled. For the bottom, I have to take away 2 of the x's. In other words, I have to subtract this exponent by 2. So 3 minus 2 gives me a power of 1. So instead of writing a 3 as the exponent, this is now x to the 1st power. So you take your lowest power, cancel that out, and the highest power you'll just subtract whatever the lower power is. Okay, now for the y's here, the lower power is in the denominator, y squared. So I'm going to cancel that out. And for the numerator, this 5 will be subtracted by 2. So if I subtract that by 2, I now have 3. So y to the 3rd power. So looking at all this, let's kind of figure out what I have left over. I have this 7, x squared got canceled out, and I have y to the 3rd power. So I have 7 y to the 3rd power over my denominator here. I have a 1 instead of this 5. So it's going to be 1 times x to the 1st power. So I'm going to write that down, 1 x to the first power. I'm not going to write the 1 because 1 times anything is just itself. So x to the first power. And then y squared got canceled, so that's all that's left in the denominator. If you look at this here, this is the exact same answer that we got the first time around. So let's try out this technique here on this next one. So we're going to take care of the numbers first. What goes into 14 and 21? Well, that's 7. So 7 goes into 14 twice, and 7 goes into 21 3 times. And now let's take a look at, actually, let me write this here as I go. So I have 2 in the top and 3 in the bottom. So I'm just taking those numbers and putting them on here. Now I'm going to look at the a's. This is a to the first power, it seems. And this is a in the bottom to the second power. So it looks like the lower power here is the one in the top. And it's a to the first power, so that gets canceled. If I subtract 1 from this 2, 2 minus 1 gives me just 1. So instead of a squared now, I just have a to the first power in the denominator. So I have a to the first power in the denominator. Now I'm going to take a look at the b's here. So this is b to the third power and b in the denominator, or b to the first power. So b to the first power is smaller, so I'm going to cancel that out. And then in the numerator, I'm going to subtract 1 from this 3. So 3 minus 1 gives me 2. So I have b to the second power in the numerator, because this b is in the numerator. Just like before, this a was in the denominator, so I'm going to put it in the denominator. And last but not least, let's take a look at c here. So it looks like c squared is the smaller one. So I'm going to cancel that out. That means I have to subtract 2 from this 3. So 3 minus 2 gives me just 1. So I have c to the first power in the numerator. And that's it. I've went through all the terms. So looking at this here, this is my final answer. This c to the first power, you don't have to write the 1 there. I just did to be explicit. So why am I showing you this technique is one of the really nice thing about this technique is it's super flexible to use. And also you avoid negative exponents. Notice I didn't have to deal with negative exponents here when I'm doing that canceling trick. So I can cancel top from bottom if I can see common factors. So now let's take a look at something different. So let's go back to elementary school when we first learned to multiply and divide fraction. Hopefully you've learned this at some point. If you don't remember, well, we're going to review it right here. So typically when I see a problem like this and we're multiplying two fractions, you want to multiply straight across. Okay, so what I mean is like we're going to multiply the numerator with the numerator, denominator with denominator. So 3 times 4 here is going to give me 12. 8 times 6 here is going to give me 48, and then you would try to reduce, so what goes into 12 and 48? Well, 12 does. So 12 goes into 12 one time, and 12 goes into 48 4 times. So I can actually, so I can actually write this as 1 over 4. And that's my final answer. But there's actually another way you can do this, and some of you might have learned this before. So another way you can solve this a lot quicker is if you look at what your common factors are diagonally. Okay, you can look if you have common factors up and down, but also diagonally. So this is what I mean. So I'm going to rewrite this problem, but I'm going to do it a little different. So when I look at it diagonally, I want to ask myself what divides into 3 and 6. Okay, so when I look at this here, I can see that what divides into 3 and 6 is 3. So 3 can go into 3 one time, 3 can go into 6 two times. And if I look at diagonally this way, 8 and 4, 4 can go into 8 and 4, 4 can go into 8 twice, and 4 can go into 4 one time. So notice what I did here is I reduced the number that I needed to multiply. So when I multiply this straight across, 1 times 1 gives me 1. 2 times 2 gives me 4. So this is really 1 over 4, and that's the exact same answer that I got before previously. So looking at this one here, I'm going to do the same thing, but this one's a division. So whenever we're dividing, we have to flip the second fraction. So let's set this up so it is appropriate. So I'm going to keep the first fraction still, change the division sign to a multiplication sign, and then I have 25 over 8. So when I multiply straight across, let's actually see instead what can cancel perhaps vertically. So 16 and 5 don't have anything in common. 25 and 8 don't have anything in common. So then you want to look diagonally and see if they have any common factors. Like 16 and 8, 8 can divide into 16 2 times. And 8 can divide into 8 1 time. For the 5 and the 25, 5 both divides into 5 and 25. So 5 can divide into 5 1 time, and 5 can divide into 25 5 times. So when you multiply this out, you would have 2 times 5, which is 10. And then the bottom, 1 times 1, is just going to be 1. So 10 over 1 is just 10. And that is my final answer. So we're going to be using these skills here in the next slide. So keep in mind, you can cancel things when you multiply or divide diagonally or vertically up and down. So keep those skills in mind because we're still going to need them later. Okay, so we're going to be talking about something called rational functions. So rational functions are basically fractions, but instead of having like a number over number, like most fractions we see as like 1/2, it's a number over another number. A rational function is when you have a polynomial over another polynomial. So if you remember what polynomial is, it just means that you have a expression that has several terms joined together, and x is to some power, it could be, but you have some like variables with some numbers. So looking at this one here, it looks like you have like a quadratic polynomial over a a linear polynomial. So this is x to the first power. So you can think of rational functions as just a fraction where the mathematical expression is written on the top and the bottom. So in the next slide here, we're going to learn how to actually solve them, or multiply, divide, and simplify using rational functions. All right, so we're going to start out by learning how to simplify a rational function. So when you're looking at these problems here, it might look kind of messy or a little bit overwhelming, right? Not the typical fraction that we're used to, where fractions that we are used to are like a number over a number. But this here is like a mathematical expression over another mathematical expression. But remember, the principles stay the same when it comes to simplifying. What we want to try to do is see if we can cancel something from the top with the bottom. In order to do that, they have to be identical. Like this first one here, you have x minus 3 in the top and x minus 3 in the bottom. So that means that they cancel, and you would have just this x, this 2x plus 1 left. So my answer here is just 2x plus 1. There's no denominator left here. So in this case, this is my answer. Okay, so now we're going to take a look at part 2. Part 2 here is not as explicit. So these bottom factors are already written as its factors, which is nice. But the numerator isn't. So when I'm looking at the numerator, I notice that, well, it's a quadratic. So for quadratics, one of the useful things that we learned is factoring quadratics. Because I can take this equation and try to factor it to see if I can cancel out with my denominator. So if I were to try to find the factors here, let's see. Let me write it this way. So what two numbers multiply to give me 10, but add to give me 7 is what it's asking if we're trying to find the factors. So I'm going to put my x's down because I need an x squared. But perhaps 5 and 2 will work because 5 times 2 gives me 10. If they're both positive, if I add them, I would get 7 plus 2, which is $11. So the top has been factored. The bottom here is going to stay the same because it's already in factor form. No reason to make it harder. And then this one here is x minus 2. So if we're looking at these two, top and bottom, we're going to try to find any similar. Okay, so when I look at this one, what I notice is that the top part here, well, the bottom's already in factor form, so I can't do much there. But the top part here, I have an x on this term and an x on this term. So what I'm going to do is bring out the lowest power x that I can. So lower power as in the lowest exponent. So what I'm going to do is they both have x's as a base. So I'm going to pull out an x squared. Because that's the lowest power. So if I pull out an x squared, because it's the lowest power, that means I'm taking an x squared from this term and this term. So if I take an x squared from here, I'm dividing out an x squared. So I have to subtract by the exponent. So that means I still have an x left over. And then on this side, if I take away an x squared, that means I have a 4 left over. This is what we call undistributing. And so look, if I take this x squared and I redistribute, that would give me the x cubed. And if I take x squared and times it by 4, I get 4x squared. And I get back to here again. So what I'm doing is I am undistributing out the common factor, which is x squared. And so that allows me to get this here, which is another factor, to try to cancel out with the bottom. And like if I were to write in the denominator here, you're going to already see it. So when I see this, you can see that the x plus 4 cancel, and so now you just have x squared over x minus 5. So two things I want you to grab from here, so this was the answer, is that when you see quadratics, try to factor that, and that allows you to maybe cancel something in the bottom, excuse me. Or when you see something that has like common terms, try to factor out or what we call undistribute. So that allows you to cancel out with other factors too. So undistributing and factoring quadratics can be super helpful when it comes to canceling out more factors. Okay, now let's try out multiplying. Okay, so multiplying fractions, we know we have to multiply straight across. But when you look at these two rational functions and you were to multiply straight across, it's kind of icky, right? You'd be taking this and foiling it with this factor. And that means you have to distribute the x squared to the x to the 7 and then take the 5x and distribute and then add up all the terms, and it's just going to take a while. So we want to try to avoid this. So one way we can do this is try to factor out. So we could factor this quadratic and maybe undistribute and see how much we can cancel before we try to multiply straight across. So you always attempt to try to cancel before you multiply straight across, because this allows you to eliminate a few things and make the multiplication a lot easier. So let's try this out. So looking at this guy here, we notice that there's a quadratic. And so we're going to attempt to factor that. So if I were to factor this part, let's see, to put two x's here. To make a 4, to multiply to get something that's 4, but add to get something that's 5, that means that I needed a 4 and a 1. And I needed additions because both of these are plus signs, so I need plus signs on my two factors. And I factored it. So looking at this, 4 times 4 gives you 4. 4 plus 1 gives you 5, so that works out. The bottom one here, notice that this is a 2 plus 8. So I notice that there's a common term here because this is a 2 and this is an 8. That means I can divide out a 2. So if I take out a 2, that means I have an x plus 4 left over. Because if I redistribute 2 times x gives you 2x, 2 times 4 gives you 8. So all I did was I noticed that they both can be divided by 2, so I took it out, divided this guy by 2, leaving the x, divided 8 by 2, that gives me a 4. So that's how I came up with this new factor. All right, let's see this other side here. So I'm going to bring down this multiplication sign. I have an x plus 7, which I really can't do much with. I can't undistribute anything, so I'm going to bring it down. And then these are two factors, so I never want to, mess with the two factors because I want to keep it the way it is so I can cancel with other stuff. So I'm just going to bring it down the way it is. And then when I look at this here, I start to see common terms, right? So diagonally, I see that the x plus 1s cancel, so I'm going to eliminate that. And I also see that vertically, this is an x plus 4, this is an x plus 4, so they're going to cancel. And so that's 4 factors that got canceled here. So when I multiply straight across the numerator, that means I only have x plus 7 left over. And for the denominator, I only have this 2. And the x minus 3. So I'm going to pull that down. And that's it. And so this is my final answer. So you can see how those skills that we've learned, factoring quadratics and undistributing, allow us to cancel, making the multiplication a lot easier because you've eliminated a lot of things. So let's try that with number 2 here. So you can see that with number 2, this right here is a quadratic, but there's only 2 terms, but it's possible that we could factor. And then perhaps, so I'm going to circle that we're going to attempt to factor. This is definitely factorable. It's quadratic. And then the 9x minus 3, I think 9 and 3 have things in common. So perhaps that's factorable. So I'm going to try to factor and undistribute here. But this one here, 3 and 1, don't have much in common. So I think I'm going to have to leave that one alone. There's not much I can do. So for the first part here, just setting this up, the x squared minus 16, this is what we call the difference of squares. So when you're factoring this, you need to make sure that you cancel out the middle term. So how do we do this? So we both need x's on both of the factors. But to make this a negative 16, well, negative 4 times positive 4 will give me a negative 16. But it will also allow me, when I add negative 4 with 4, they will cancel out. So that means I don't have a middle term. So anytime you notice that you have an x squared with a number that's a perfect square, in other words, 2 numbers multiplied gives you that number, like 4 times 4 gives you 16. This is what we call the difference of squares. Okay, I factored up the top. The bottom here has a 9 and a 3, so that means I can factor out a 3 because that's the common denominator, so, or the common factor. And so this here is a 9x. If I divide out a 3, that means I have a 3x left over. If I divide out a 3 with this negative 3, that means I have a negative 1 left over. Okay, so I factored out the bottom. This side, the 3x, like I said, you can't really do much with that. 3 and 1 don't have much in common. But the bottom here, you could try to factor. So let me set up my x's. Now, I have a negative 24, so two numbers that multiply to give me negative 4, but add to give me 2. That could possibly be 6 and 4. There was a positive 2, so the 6 needs to be a positive, and the 4 needs to be a negative. So if I take positive 6 and add it with negative 4, I get that middle term, that positive 2. All right, hard part is over. Now we're going to try to cancel out things. So I noticed that there are 2x minus 4, so that cancels. There's also 3x minus 1, so that cancels. So in the top part here, when I multiply straight across, I just have this x plus 4. So I have just x plus 4 in the top, and the bottom here, I have 3x plus 6. And that's it. I might not have mentioned this, but you don't need to distribute this 3 into the factors or this 2 into the factors. It's not necessary. You can do it, but like I said, you don't have to. All right, let's try out division next. Okay, last but not least, for division, remember that if you have two fractions here, or two rational functions, you're going to have to flip the second one, because that's the principle for dividing fractions, is to flip the second fraction and then change the sign to multiplication. So that's what I'm going to do here. So we keep the first fraction the same. So I'm going to hold that one still. I change the division sign to a multiplication, and then I flip the second. And now I'm going to try to multiply. So this ends up being very similar to the multiplication problem. So before I try to do that, I'm going to see if I can factor anything to cancel stuff out. So this r minus 8, there's not much I can pull out from there, and neither from this r minus 2. But in the bottom here, I notice there's a quadratic. So I'm going to try to factor that. And then perhaps the 2r plus 6, because I know 2 and 6 have common factors. So I'm going to see if I can undistribute with that one. So like I said, the top I really can't do much. The bottom here I'm going to try to factor. So two numbers that multiply give me negative 6, but add to give me, I guess, 1, positive 1. So I need my two r's, because there's an r squared. And then perhaps 3 and 2 would work if 3 is a positive and 2 is a negative. Because if I multiply, I would get the negative 6. But if I add positive 3 with negative 2, I get that positive 1. So this one works out. And then here are 2, like I said, not much I can do there. It's pretty, there's not any common factors. But the bottom here, 2 and 6, looks like we can divide out a 2, right? 2 and 6 both can be divided by 2. So if I pull out a 2, I have r left over and I think a positive 3. Right? Because I divide this by 2, I'm just left with an r. If I divide this by 2, I just have a 3. If I redistribute, 2 times r gives me 2r, 2 times 3 gives me 6. So when I look at this, I've factored everything, undistributed everything. Now I'm going to see if I can cancel out stuff. So r minus 2 cancels. And I know it's so tempting to try to cancel out this x plus 3 with this x plus 3, but you can't. Because remember, the rule of thumb is that you can cancel out diagonally or vertically up and down, but you cannot cancel if they're both on the same side. Okay, this x plus 3 will eventually be multiplied straight across with this x plus 3. You cannot cancel those out. So that means that this is all we can cancel, and that means if we that means if we multiply straight across, we have r minus 8 in the top, and in the bottom we have r plus 3 times, there's a 2 here, so I'm actually going to put that in the front. Then another r plus 3. So you can write your answer like this, or there's another way you could write this. Notice that there are two factors of r plus 3. I think I forgot a parentheses. fix that. So there we go. So notice that there are two factors that are the same. So you can write this as one factor, but squared. That's what I'm going to do. So you don't have to, but you can write it this way to make it look like a lot cleaner. And also, I mean, this could definitely be a possible multiple choice question, and you might not see this answer, but you might see this answer. So good to show. And that's it, guys. So I hope this helps with you on page 1 of the packet. So now check out that, and also check out the video that I've made for the homework on page 1 of the packet. I've done 4 of the problems in that video, so check that out if you need extra help.